Dear mentors, in this video we'll explore some problems related to percentages and proportionality, and we hope that you can use this video to replicate these methods which are visual. So remember that in other videos we've explored the bar modeling method, and we've also explored conceptual understanding versus procedural understanding. So in this video, we want to bring these elements together and use visuals to be able to tackle these problems conceptually. So let's go ahead. The first thing I want you to see, it's a good reference that you could show your students that talk about percentage change. So this is a percentage change number line. So as you can see, 1 means 100%. And then you could talk about, for example, 1.2, it would be 20% more. So this would be 20% more. Or you could say, for example, 0.75 here, that would be 20% less or 20% discount. But you can also relate it to fractions. So this is also 3/4, or is also 0.75, etc., etc. So this number line actually helps your student have a good framework to work with these problems. So let's consider the first problem, which is the following. An NBA game lasts 88 minutes divided into 4 quarters. Then each quarter lasts a total of how many minutes? So here's one visual way you could do this. So you got the whole NBA game, and you know that that NBA game has a duration of 48 minutes. And then we're being told that it's divided into 4 quarters, and that's why they call quarters. So you could break it into 2, then break it into 2 again, and that's how you break it into 4. And then what we're being asked is, what's the duration of each of these quarters? And so what we can see is that if we divide 48 by 4, then we would get the answer. Now to divide 48 into 4, we first divide it into 2, and we can do it mentally if you want to. That's 24. And then divide it into 2 again. And that's going to be 12. Let's put a 12 here. And we can check that 12 plus 12 plus 12 plus 12 is 48. Of course, you could solve this problem faster. You could just say just divide into 4. But actually drawing a picture can help the student really understand the concept. And don't be afraid to do it even in very simple problems, because it just builds understanding, and then it helps when the problems get more complicated. Let's look at the second problem, which is the following. If a movie lasts 50% more than an NBA game, then the movie lasts a total of X equals to minutes. Let's remember that NBA is equal to 48. In terms of duration. And so what we want to do is draw a bar diagram, so bar model. And so remember that 50% more means 1/2 more. So what I want to do is break the NBA game into 2 units, and then take the movie to be 1/2 more of whatever the NBA game. So this is the picture that you want to create. NBA here and movie here. So this is how bar modeling is so helpful to visualize percentages. So this is 50% more. Now the NBA is 48. So if this total is 48, we right away see that these pieces have to be 24 and 24. And since all these pieces are equal in the whole model, this should also be 24, 24, 24. And so by a nice addition, when I add 24, 24, 24, I can add first the 20s, get a 60. I can add the 4s, get a 12. And I can add 60 and 12 and get a 72. I really encourage you to use this so-called tree addition, or in other contexts you could call it connected numbers, because it builds number sense. So that should be the answer, that the movie is 72 minutes long. How would you do it with algebra? Or how would you do it rather than algebra, like with other methods that are a little shorter, a little faster? Well, you could say that the movie equals to 1.5, because that's how we could do it with decimals, times the NBA game. And then you could do 1.5 times 48. And then probably the best way would be to do fractions. 1.5 is 3/2. So this method has the advantage that you're translating to fractions, so you're checking for this understanding. And then when you multiply a fraction by a number, it's probably more useful to do the division first. So 3 times 48/2, which would become then 3 times 24. 72. So that's another way you could solve this problem. Let's move to the third problem. If Fernando watched 60% of an NBA game, then Fernando watched a total of how many minutes? And so here what we want to do is an approximation and say that 66% is approximately 2/3. And why is that? Well, because 1/3 corresponds to 33.333 forever percent. Or just like that. Yeah, 1/3, 33%. So this approximation is good. 66% is roughly that. So how can we do this? It's the same idea. You got your NBA game, break it into 3 equal parts, and he watched 66%. So 66%, 2/3. Since the NBA game has a total duration of 48, what I really need to do is break this 48 into 3 equal pieces. So how am I breaking 48 into 3 pieces? One way is to break first 48 into 30 plus 18, so that when I divide by 3, I get 10 plus 6, which is 16. And so I can put 16 here, 16 here, and 16 here. And now my answer is clear. 16 plus 16, it should be 32. Let's look at the last video, the last problem from this video. Sylvia trained 120% of the duration of an NBA game. Then Sylvia trained for how many minutes? And so we do a bar model again. So our unit, our total, and we know that 20% means breaking into 5 parts, because 20 times 5 is 100. So I'm going to break this into 5 equal parts. And I'm going to take Sylvia to have 1 more part, because she's 20% more than the NBA game. And so this is NBA, the total. And this is Sylvia. And of course, we're talking about not the NBA itself and Sylvia itself, but the duration of the activities that corresponds to this game and people. So we know that the NBA game is 48 minutes. And so now what we want to do is find what is 48 divided by 5. And there's a trick on dividing by 5, which is we multiply and divide by 2 just to get a 10 on the bottom. And 48 times 2 is 96, because 50 times 2 is 100. So 48 times 2 has to be 4 less. And so this is 9.6. And the meaning of this 9.6, it's not the final answer yet, of course, but it's how big is each of these parts. So we're going to put a lot of 9.6 here, pretty much everywhere. And that gets us 48. And these are the same. So what we want to say is that what Sylvia trained is 48 plus 9.6. And so you could do this in many ways. One way would be adding 9.6 is adding 10, and then subtracting 0.4. And so this is 58 minus 0.4. And this is 57.6. And so that would be the answer, 57.6 minutes. So I hope you like this video, and I encourage you to try this visual method to complement just doing procedures right away. That should be kind of hard maybe in the beginning for students, because they may not be used to actually having people care for their conceptual understanding. They're just not used to that. But if you do this consistently, they'll be much more motivated, and they'll actually, have more joy for learning mathematics. Thank you.